In this video, we're going to consider adding and subtracting algebraic fractions, and this is a really common technique in early algebra classes like Algebra 1, but it will also come up a lot in more advanced classes. It just happens to be that we often have to add, subtract, or work with algebraic fractions. So the absolute key to mastering this technique is not to work with algebraic fractions, but to start with numerical fractions, and that's because the rules are essentially identical, and that main rule is that you can only add or subtract fractions, whether they're numerical fractions or algebraic, if they've got common denominators. That's literally the only way you can do it. So if you've already had some experience with numerical fractions and you remember how those rules work, obviously the algebraic ones look very different. They can look quite intimidating, but if you keep in the back of your mind that essentially you're just going through the same process with these, as you're hopefully already familiar with these, and that can help make it a little less intimidating and easier to remember the method. So let's start by doing a little recap and going back to these numerical fractions, picking up the technique, and then we'll apply that to these algebraic fractions to show that it is a consistent process across the different question types. Let's start with the most easy case where you've already got common denominators. So here we've got 2 7s plus 3 7s. Both fractions are already in sevens, so we've got the same denominator, common denominator. So very little work to do here. We can just add them together. 2 plus 3 gives us 5 sevens. The thing to not do there is to add the sevens together to make a 14, which is a really common mistake because we're working in sevens. So you've got 2 of them, then you're adding 3 of them, so you've got 5 of them, 5 sevens. So that's the easiest case. Just as a quick reminder, this case here, a little more complicated because we've got a denominator here of 3 and here of 6, so we've got thirds and sixths, which are different types of fraction, so we can't just add them directly. So what we've got to do this time is make a common denominator. One way you could achieve that here is to turn your 2/3 into an equivalent fraction that's got a denominator of 6, and you could achieve that by multiplying the fraction top and bottom by 2. So it's a really important point this. You're always allowed to multiply a fraction or divide it top and bottom by the same thing. As long as it's the same number top and bottom, that just makes what's called an equivalent fraction, which is the same number just written in a different way. So if we multiply this top and bottom by 2, then it's going to turn into the fraction 4 over 6. So if you were to put the number 2 over 3 into your calculator and then 4 over 6, you would get the same decimal number. They're the same number written in a different way. 2/3, 4, 6 are the same thing written in a different way, but now it means that we can add that to our 1/6 because it's got a common denominator. So we've had to just work a little harder in this question to make the common denominator, and then we can go ahead and add together. So quite easy case here, slightly trickier here. The next one more tricky. So it doesn't matter the fact that we're subtracting. These rules, these ways of making common denominators work for adding or subtracting. But here we've got a minus, which does put some people off, but don't worry too much about that. But there's nothing we can do here equivalent to what we did here, because you can't multiply 4 by any whole number to get a 5, or 5 to get a 4. So we need to take a different approach. And this is the approach that's going to be most applicable. This is the example really to focus on. It's the one we're going to use mostly in algebraic fractions as well, but it's also important for number fractions. So we're going to do a similar thing here by making new fractions. And we're going to multiply our denominators together. So multiplying the 4 and the 5 to get 20s. So this approach will always work, multiplying your denominators. Some people like to put a little line to say they've multiplied those. And that gives us a new common denominator of 20. But then obviously we need to adjust the numerators. We can't just change the denominators. And to achieve that, we cross multiply. So we're multiplying the 5 up there and we're multiplying the 4 up there. So 5 multiplies to the 3 to give us 15. 4 multiplies to 2 to give us 8. Essentially all we've done, we've taken the 3 over 4 and we've multiplied it top and bottom by 5, and we've multiplied the 2 over 5 top and bottom by 4. So you're essentially multiplying each fraction top and bottom by the denominator of the other fraction. That's how some people like to think of it. Some people like to draw these lines on to remember how to multiply. But whichever method you use, we've ended up with two fractions that have got the same denominator, and these two fractions are the same as the original two, just written in a different way. They're the same numbers in a different equivalent fraction form. 15 minus 8, we can just do that now directly. That gives us 7, so it's 7 over 20, and that is our final answer. So common denominators were already there, so we were good to go. A little bit more work here. We had to change one fraction, This one being the more common case, we had to change both denominators to make a common denominator. Right, so that's a little recap really of number fractions, but we're just going to take the same technique into these algebraic fractions. What is an algebraic fraction? Unsurprisingly, it's a fraction that's got algebraic terms in it, so really not as profound of a thing as it might seem, but like I said earlier, they are very important. They do come up in a lot of techniques. So there's two different cases in a way. You've got cases where you've got you've got denominators are numbers, like numerical values, and you've got cases where the denominators are algebraic values. This one is probably a little trickier, but essentially just the same technique. We're just making common denominators. So we're going to go with this method. This is essentially the approach we can take with all algebraic fractions or numerical fractions by taking the original fractions and changing them. So we're going to multiply these two denominators together. That's going to give us two new fractions, which are in terms of twelfths. Multiplying the 4 up here to the 2x to give us an 8x. The 3 goes up to the x to give us a 3x. So we've just done exactly the same as we did here. It's just that these have got algebraic terms in addition to numerical terms. Now they've got the same denominators, we can add them. So 8x and 3x is 11x, and the common denominator stays as 12. So really just an identical approach to what we did here. Let's move on and try this guy. And again, we're just going to do the same thing. We're going to take our original fractions and make equivalent fractions. That's always the key, starting by making new equivalent fractions. Multiply the denominators together to get 30. Cross multiply again. Be careful when you cross multiply when there's multiple terms. So the 6 needs to multiply to both of those. So 6 times x gives you 6x, 6 times 2 gives you 12. The 5 multiplies up here. And again, if you want to draw on the little arrows, if that's useful, then go for it. Like a lot of my students do that. 5 times x gives you 5x, 5 times minus 3, note the negative there, gives you minus 15. Then you just need to add them together. So adding them together, remember, just means adding the numerators together. So we're adding that numerator to that numerator. You can write that if you wish on a line of working. But remember, when you're adding terms like this, you can only add the like terms. So the 6x will add to the 5x, you can only add the numbers together and the x's together. So 6 plus 5 gives you 11, so that's going to be 11x. 12 minus 15 gives you minus 3, and that is just again over the denominator of 30. So more common example, probably less common, but again just the same technique essentially on both. So those two had numerical denominators. Let's look at the two examples where we've got algebraic denominators, but again just keep in your head that it's not a different technique, it's not a different question type, it's just a slightly different scenario using the same technique. So again, we're going to multiply these together and we're going to cross multiply. The only thing about these, when you multiply these together, x minus 2 and x plus 5, you don't really need to multiply them together. So what you want to do in a question like this is make your equivalent fractions by multiplying these together by sitting them in brackets beside each other. Remember, a bracket beside a bracket implies multiplication. It means that the two brackets are being multiplied. We just don't need to actually multiply them. We don't need to multiply out the brackets. Just put them beside each other, and that's good enough. In fact, that's what you want to do in a question like this. So what we've done there is we've multiplied those together. Now we're going to cross multiply. So the x plus 5 goes to the 3. The 3 is multiplying to both parts of the x plus 5. So 3 times x gives you 3x. 3 times 5 gives you 15. It's really tempting to only multiply the 3 to like the x and forget about the 5, but it's got to multiply to both. The same with the 2. 2 times x gives you 2x. 2 times minus 2 gives you minus 4. And now we've achieved our equivalent fractions, which have got common denominators. So it's no more different really than this case or this case or this case. We've achieved the common denominator. Now we can just add them, or it could be a subtract. It's an add in this case. 3x plus 2x gives you 5x. 15 plus minus 4, that's just 15 minus 4, which gives you 11. So 15 minus 4, 11. And that's just all going to be over the denominator x minus 2, x plus 5. So you'll end up with that 2 bracket denominator. Or sometimes you'll see just an x on the denominator there. That would just end up as a x and then a bracket. Okay, and that's a very common form, that one that we've just worked. Let's look at one final case. So be careful with the negatives in these questions. Remember, if you're subtracting a fraction like this, it's got 2 parts, you could potentially end up with like a double negative. So watch out for that in various examples. So just doing the same thing again, let's make our two new fractions. And I personally like to write out those two fractions like this first, and then figure out my denominators first of all, which is going to be just again the x plus 3 multiplied to the x minus 7, just like this. So just writing those guys in brackets. Sometimes you'll see the original question already with these in a bracket. It doesn't matter if there's a bracket there originally or not. We're just going to put them in brackets if there are no brackets. And then just cross multiplying. So 5 times x, 5x. 5 times negative 7 is minus 35. 2 times x is 2x, and then 2 times 3 is 6. Just keeping an eye on your signs. Watch out for plus minus errors in these questions. That's really common. And then again, we're just going to combine them. So 5x minus 2x is time. So it doesn't matter if it's a plus or a minus. Just perform whatever operation you've got to perform. 5x minus 2x gives us 3x. Minus 35 minus 6. So be careful because that minus, remember, applies to that number as well. Minus 35 take away 6 is minus 41. And that's just going to be over, again, our common denominator. So a really useful technique. That technique will appear in Algebra 1, Algebra 2, all sorts of classes, calculus classes. So it's really good to get this one down early so that you're comfortable with it. And it is really just an extension of the case with the number fractions. If this is all brand new to you, I would say work some number fractions first, get comfortable with that, then move on to the algebraic fractions, because really they are just the same method with slightly different fraction types. So that's how you go about adding and subtracting algebraic fractions.